Welcome back. We are doing the second last question of the 2017 HSC General Maths paper. It is question 29, and of course the first question is everybody's favorites, Simpson's rule. 29A. A new 200-meter long dam is to be built. The plan for the new dam shows evenly spaced cross-sectional areas. So instead of lengths, we're given the areas. 1. Using two applications of Simpson's rule, show that the volume of the dam is approximately 44,333 cubic meters for 2 marks. Okay, usually you use Simpson's rule to approximate areas, but since we're giving the areas instead of the lengths, we can use Simpson's rule to approximate the volume. I'm just going to write the formula real quick. Since it's 200 meters all the way across, that means each section is 50 meters. Therefore, the height is going to be 50 meters. The first Simpson's rule will cover this volume. This will be V1, and the second application of the Simpson's rule is going to cover that volume, which I will call V2. And then I'll add them together and we'll have the volume of the whole thing. So V1 is going to be approximately 50 on 3. The first area is actually 0 because that's the area over here, which is no area, 0. Plus 4 times the second area, which is 140. Plus the last one, which is 270. Then I'm just going to do that on the calculator. And that's in cubic meters. Then volume 2, we're going to do the exact same thing, but with the measurements of the other areas. The height is the same, still 50 meters. The first one is going to be 270 plus 4 times 300 plus 360. Oops, ran out of room there. Let me just squeeze it in. That is going to be 30,500 cubic meters. Then we add them together. We get 44,333.333. And then of course you would do another line to round it to the nearest cubic meter, like how the question told you to do. And we're done. Show that the volume of the dam is approximately 44,333 cubic meters. Let's see what the answer says. So they did it all in the one line, which you can also do. And yeah. Second question. It is known that the catchment area for this dam is 2 square kilometers. Calculate how much rainfall is needed to the nearest millimeter to fill the dam. It's basically asking if we have a pool. So I'm just going to quickly draw. This is the floor of the pool. And the floor of the pool is 2 square kilometers. How many millimeters of rain? So how tall do these walls have to be when the water fill it up, it will have a volume of 44,333 cubic meters. Basically, how many millimeters tall is this rectangular prism have to be if the base of it is 2 square kilometers and rain just keeps on pouring in? First of all, I don't like the disparity of units. There's meters, there's kilometers, and then there's millimeters. So I'm going to change this square kilometers to square meters to begin with. 2 square kilometers is the same as 2 million square meters. Now we can continue. We know that volume is length times breadth times height. And we can start substituting some of the numbers in here. For example, we know the volume. Volume is 44,333. The length times breadth would be 2 million. And what we want to find is the height. Therefore, the height is going to be 44,333 divided by 2 million. 0.022165 meters. However, we want it in millimeters, so we have to times 1,000, and that will give us 22.1665 millimeters. Let's see if the question asks to the nearest millimeter. Then we spend another line to say, therefore, it will take 22 millimeters of rainwater to fill up the dam. Let's see what the answer says. There you go. Wonderful. Question 29b. Sabrina's taxable income is $86,000. I should write this down. $86,725 in a particular year. The table below is used to calculate her tax payable. In addition, she pays the Medicare levy, which is 2% of her taxable income. And this is her taxable income. Okay, let me just write that. Taxable income is that much. Her Medicare levy is 2% of her taxable income, which is $1,734.50. Okay, so her taxable income is just below 87,000, which means she's still in this bracket here. That means she's got to pay 3,500. Oh, actually, read the question first. Calculate Sabrina's net income. Net income. Okay, so after tax. Alright. Let's calculate her tax first. Her tax will be $3,572 plus 32.5 cents for each dollar over $37,000, which is another words of saying 32.5% of anything over $37,000. So 32.5% of 37,000 minus, nope, sorry, wrong way around, of 86,725 minus $37,000. That equals that's $3,572 plus 16,160.625 is is 19,732.625. The net income, I'm just going to the net income is going to be 86,725, so her total income minus the Medicare levy and then minus her tax. That is 65,257.875, which is in dollars $65,257.88. Let's see the answer. Oh, they rounded it. Now the reason why we didn't get the answer that's on the answer sheet is because they rounded the number before doing another calculation. Now, when I was doing 3-unit maths, this was a big no-no. You do not round anything until you get to the very last line. However, I can see where they're coming from, because you pay that much to the tax department, and of course they would round it there to pay to the tax department. However, it's not good practice to round a number if you're still going to use it for a different calculation later on in the question. So maybe something to ask your teacher about, or ask a HSC marker to see what the rule on that is. 29C. A group of Year 12 students were surveyed. The students were asked whether they lived in the city or the country. They were also asked if they have ever water skied. The results are recorded in the table. Question 1. A person is selected at random from the group surveyed. Calculate the probability that that person lives in the city and has never water skied. 2 marks. He lives in the city and has never water skied, so that's 2,500 people. The probability would be 2,500 over the total. Let's do it. Let's find the total first. It's 3,520 people. The probability of in the city and never water skied is 2,500 over 3,520. Then you find the simplest fraction, which is 125,176. Let's see the answer. Got it. Number 2. A newspaper article claimed that Year 12 students who live in the country are more likely to have water skied than those who live in the city. Is this true based on the survey results? Justify your answer with relevant calculations. Let's do the city first. We need the total for the city, which is 150 plus 2,500. That's 2,650 people. The total for the country is 70 plus 800, which is 870 people. The probability of people in the city and who have water skied is 150 out of 2,650, which is 0.0566 0.03 ... and I'm going to leave it in decimal form so it'll be easier to compare. And the people who live in the country and have water skied is 70 out of 870, which is 0.080459 ... And as you can see, the people who live in the country have more of a chance of having have water skied than the people who live in the city, because there's an 8% chance that people who live in the country have water skied versus only a 5 to 6% chance of people in the city water skiing. Therefore, the statement is true because of these relevant calculations. Let's check the answers. Okay, 8% of people water skied in this country and versus 5% of people who water skied in the city. Therefore, the claim in the newspaper is true. Next question. 29D. All of the students in a class of 30 did a test. The marks out of 10 are shown in the dot plot. Find the median test mark for 1 mark. The median would be the middle of those marks, so it would be between the 15th and the 16th mark. Alright, so this has 1, 2, this is 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So the 15th and the 16th mark are 4 and 8. We need to find the average of 4 and 8, which is 6. Therefore, the median test mark is 6. Let's check the answers. Yep, perfect. Next question. The mean test mark is 5.4. The standard deviation is 4.22. Using the dot plot, calculate the percentage of marks which lie within 1 standard deviation of the mean. This sounds incredibly confusing, but it's actually not too bad. So the average is 5.4. So if we have a bell curve, it's a terrible bell curve, but you get the point. The the average would be 5.4. 1 standard deviation below and 1 standard deviation above would be 4.22 away from 5.4. 1 standard deviation below would be 1.18. And 1 standard deviation above would be 9.62. Then we just have to find all of the marks that's in between that and then find the percentage. So calculate the percentage of marks which lie within 1 standard deviation from the mean. From between 1.18 to 9.62, that means we don't get the 1, we get 2. That means everyone that has marks between 2 and 9. I'm just going to count them. There's 6 over here, 7, and then another 6, so that's 13. 13 people got within 1 standard deviation. Therefore, the percentage is going to be 13 out of 30. Which is 0.43 repeater, and that is equivalent to 43%. Let's see what the answer says. Yep, 43.3%. Okay, they wanted it to 1 decimal place. 43.3%. Let's go next question. Question 3, a student states that for any data set, 68% of scores should lie within 1 standard deviation of the mean. With reference to the dot plot, explain why the student statement is not relevant in this context. 1 mark. Since it is only 1 mark, I'm not going to spend too long answering the question. Basically, I'm going to say that first of all, the class is only of 30, which is not a very large sample size to begin with. And second of all, if you look at the dot plot, it does not resemble anything like the bell curve at all. In fact, it kind of looks like the opposite of a bell curve. So any rules regarding anything to do with the bell curve, standard deviations and all that, will not be able to apply to this dot plot. Let's see what it says in the answers. The dot plot does not show a normally distributed data set, so the statement is irrelevant. In other words, the dot plot doesn't look like a nice curve shape, therefore it's irrelevant.